Hi everyone, welcome to my new YouTube channel Reactive Minds by Anchal Muttama. In this channel, I'll be mainly talking the topics related to chemistry, covering from organic, inorganic as well as physical chemistry. And I will work towards making the complicated topics easier and understand in a better ways. For more tricks and tips related to chemistry, keep watching Reactive Minds. In today's video, I'll be speaking about one of the easiest reactions in organic chemistry, that is Aldol condensation. I hope everyone will be familiar with this topic. Aldol condensation mainly revolves around aldehydes and ketones. As we move to the definitions, it says aldehydes containing a alpha hydrogen atom undergo a reversible self-addition in the presence of dilute alkali to give condensation product is called aldol condensation. So to understand betterly, firstly we'll see what is alpha hydrogen atom. The hydrogen atom, which is directly bonded to the carbon atom adjacent to the carbonyl compound, is known as the alpha hydrogen atom. The carbonyl compound is nothing but any organic compound which contains the C double bond O. So, whatever hydrogen which is attached to the carbon present next to the C double bond O is known as the alpha hydrogen atom. This kind of compounds in the presence of dilute alkali, that is nothing but NaOH, will undergo a condensation reaction to give the aldol as the product. Aldol is nothing but the combination of both aldehyde and alcohol. But in case of ketone, it gives ketol. That is the combination of both alcohol as well as ketone. So, here I have taken two examples of both aldehyde as well as ketone. Firstly, we'll see about the aldehyde. Here, in the first example, I have taken two molecules of ethanol in presence of dilute NaOH. It gives 3-hydroxy butanol, that is a aldol. So, in case of this ethanol, we can see that it is bonded like CH3 C double bond OH. So the carbon next to the C double bond O carries 3 hydrogen atom. In that, one of the hydrogen will become a alpha hydrogen. So containing the alpha hydrogen is a compulsory in aldol condensation. So next example, we'll see about the ketone. Here we have taken two molecules of acetone in presence of the dilute NaOH gives 4-hydroxy 4-methyl pentane 2-one. So as we have discussed about the reactions, next we'll move on to the mechanism of this reaction. The mechanism of aldol condensation can be mainly divided into two main steps. The first step is the deprotonation of alpha carbon, and the second step is the aldol addition along with protonation. So coming to the first step, that is the deprotonation of the alpha carbon. In this step, the base, whatever present in the reaction, the base here is the NaOH. This NaOH dissociates as Na plus and OH minus. This OH minus ions, that is the hydroxide ion, removes a proton from the alpha carbon atom to give the carbanion. This carbanion is a nucleophile. In the second step, you can see there, that is the aldol addition takes place. Here The nucleophilic attack of the carbanion on the carbonyl carbon of another molecule gives anion. That is, whatever the carbanion we have got from the first step will attack the electrophile, that is the another aldehyde molecule, to give the anion. This anion picks up a proton from the water molecule to give the aldol as the product. So this is the simple mechanism of aldol condensation. Hope you all understood and it's easy for you. So next, there is another small topic in aldol condensation, that is cross aldol condensation. So now we'll see what is cross aldol condensation. Here the reaction or the condensation reaction here mainly takes place between either two different ketone or two different aldehyde, or between the ketone and the aldehyde. So next we'll see the examples for these reactions. So first example is, we have taken two different aldehydes. That is, here we have taken benzaldehyde along with ethanol, that is acetaldehyde. So in case of aldol condensation, it takes place between the same molecules of aldehyde. But in cross aldol condensation, it takes place between the two different aldehydes or the ketone molecules, or in between the ketone and the aldehyde. So here benzaldehyde and ethanol will react in the presence of the NaOH to form the 3-hydroxy 3-phenyl propanol, that is a aldol. Here you can see that in the second example, I have considered a reaction between an aldehyde and a ketone. Here I have considered formaldehyde as well as acetone. Here formaldehyde is a aldehyde and acetone is a ketone molecule. Here these two molecules will undergo condensation reaction in the presence of alkali, that is the NaOH, to give 4-hydroxy butane 2-one. This is the cross aldol reactions. Coming to the end of this video, let us discuss about the difference between the aldol and the cross aldol condensation. So here we can see that first, aldol condensation is a reaction which involves between the two molecules of same aldehyde, whereas cross aldol condensation takes place between the two molecules of different aldehyde or ketone, or between the ketone and an aldehyde. Here aldol condensation typically involves self-condensation reaction, whereas cross aldol condensation, here molecules will undergo condensation with another molecule, resulting in the formation of the mixture of products. So in aldol condensation, it leads to the formation of a single type of beta hydroxy carbonyl compound. But in case of cross aldol condensation, it results in the formation of the mixture of different beta hydroxy carbonyl compounds due to the involvement of the distinct starting materials, that is the different starting materials. So due to the presence of the different starting materials, what happens? We get mixture of the products. Hope you all have understood the topics. If there is any doubt, please drop it in the comment section. And thank you for watching. Please don't forget to like, share, comment and subscribe.